Well, if that's clear as mud, let's start on 6.3, factoring trinomials with a leading coefficient of 1. It's pretty crucial for us that this leading coefficient be 1, because it allows us to use a rule which allows us to take a shortcut. Although I'm going to show you how not to take the shortcut, which, in case you forget the rule, allows you to do this anytime, and it's pretty much the method you're going to be using in 1010. Whether we see it in the future for this particular class or not, doesn't matter. I'm still going to show it to you guys, okay? So this is kind of the rule for it, but like I said before, when you see a trinomial like this, what we end up looking to do is to factor by grouping, which allows us to split this middle term up in half, or not in half, but in two terms, okay? Whatever two terms that ends up being to help us to factor by grouping. Okay, but what's nice about this is if the leading coefficient is it's a phantom 1 right there. If it is a phantom 1, then it allows us to use this rule. Okay, so what you end up with is two binomials being multiplied, where the first term is x, and then you're looking for two factors of c, and this is where, again, with all the factoring that we're going to be doing, this is where students tend to break down, right? Like I can distribute, I can solve equations, but I can't factor it because there's a lot of rules involved. So again, if you can just look at this as without the rules, I guess it'd be fine, but that'd be factoring by group, okay? But we can use the rule. If you're looking for two factors of c, it doesn't have to be prime factors, just any two factors of c that add up to whatever the b value is. So we got the phantom 1, the b would be a number, and then the c would be a number, okay? Just like we saw before when we saw x to the power of 2 plus, after we combined it, like it started out as 2x, maybe it was 3x, doesn't matter, but 2x plus 3x plus 6. Remember when we saw this problem? And then we said, well, you could have combined your x's right here to get 5x's. So that would have been x squared and then positive 5x and then positive 6. So what we're saying now, and we saw how that factored out, right? So if you start with a trinomial where that leading coefficient is 1, you can start your binomials right now. Okay, and say, well, I know there's going to be x's there, automatic. All I'm looking then for is for two factors of 6 that add up to 5, and then they kind of gave us, in that problem they gave them to us, but remember that'd be like 2 and 3. Okay, well, 2 times 3 is 6. Now these are prime, but I'm not circling these because I don't care that they're prime. I just know that if I take 2 and add 3, I get 5. Okay, so that means that these two other values would be 2 and then 3. It doesn't have to be in that order. You could do plus 3 plus 2. But this was the factored form of what we had ended up starting with right here, even though we had used factoring by grouping on that, okay? To me, the rule's extraordinarily convenient if you can just memorize it. But we don't deal with, I don't know a lot of people that go home and like, dude, I factored all day long. Where if you did, I don't even know the context where you're doing it. But if you do it, hey, hooray for you, you know? So I'm going to demonstrate this factoring by grouping, and then we'll use the rule, and you can judge for yourself which one you want to use. But I think you'll see which one is more convenient if you just memorize the rule, right? So factoring by grouping means that I would be looking for factors of 24 that add up to 10, and I should be able to find them, okay? Now, the most common one is just to say 1 and 24 itself. It's just that if I add these together, I know I get 25, okay? So 25 is not 10. I need it to be 10, though, okay? So I would go to my next factor. I'd say, well, divide it by 2, right? Now, that'd be 2 and 12. It's just if I add these, I get 14. It's still not 10. I need it to be 10. Positive 10, by the way. Oh, dang it. Well, let's keep going then. So I could do 3 and 8. Hey, that's pretty close. 3 plus 8 is 11. It's just not 10. Okay, so I got to keep going. So I'd say, well, how about 4 and 6? Hey, that one looks like a winner. 4 plus 6 is 10, okay? Now, what that does, at least when we're factoring by grouping, it tells me what I need to split my 10x up into, okay? So 10x now is 4x's and 6x's. It's positive 4x. Now we still have that x squared in the front and also the positive 24 there, okay? Now this will become especially useful when the leading coefficient is not 1, because we're going to be using the rule. But from here, then we could use some factoring by grouping. I'll kind of speed this up so we can get through it. But I'd say, look at this grouping right here. I got x times x, and then 4 would be 2 times x. So I got x's that are common. I can factor those out, and then whatever's left over. I got the x, and then the 2 times 2 is 4, okay? So that's factoring, that first one, and then I'd factor the second one. So 6x would be 2 times 3 times x, and then 24, I want to take a shortcut, but I'm not going to. I really want to, though. So that'd be 3 times 2 times 2 times 2. Yeah, I think I got that. Okay, so what do we got in common there? I got a 3 and a 2, and then a 3 and 2, so that'd be 3 times 2 is 6, so that's positive 6. Well, what was left over? You got the x from the first term, and then 2 times 2, x plus 4. See, they match, so now I can yank out that x plus 4, and then I'm just left with the x plus 6. Okay? Now, that would be the answer right there, but I want you to notice that the rule is telling us, look, what you could have done is you could have set these two binomials up with the x's to start with. Then you're looking for any two factors that add up to the middle coefficient. Well, we already found those. Remember, 4 and 6? So you could have just put plus 4 plus 6 right there and skipped some of this extra work. Okay? And notice it's the same answer. That's on purpose. And, you know, however many years ago, some math nerd was like, look at this pattern right here. It's so freaking awesome. And they loved it. And now you have to learn it. Or at least memorize it until we take the test. So yeah, if that leading term was x to the power of 3, then we should be seeing x's in all three terms to factor these out. This only works if it, and this is considered a quadratic, if it's in this form, really it's ax squared plus bx plus c, which is standard form for a parabola. I could be off on my terminology there, but give me a little leeway here. But yeah, it has to be x squared there in the first term. So the nice thing about this is if you wanted to check, I don't know anyone that wants to, but if you needed to check because you felt like you wanted to make sure your answer is correct, which I recommend, then you could distribute this x into this parentheses and the 4 into this parentheses and just make sure that it would eventually simplify into what you started with. Okay, but now that we've seen that the rule works, and again, our objective here is not really to use factoring by grouping or splitting up this middle term, I'm going to be using this rule. Okay. All right. So yeah, this term right here, and like I said before, this is kind of the basic format for us. It's ax to the power of 2 plus bx plus c. Okay. Where the a, b, and c are numbers, and so we need that leading coefficient to be 1, which it is. And you can make it a phantom 1. But what we need right here is to look at factors of negative 30. Excuse me, factor pairs, I guess you could say, of negative 30. Now, I would say 1 and 30. That would be the first one I'd start with. And it doesn't really matter which one you make negative. I just kind of want to list all the factor pairs first, because 30 is not too bad. Like you could say, well, 2 and 15, right? Or 3 and 10. Or 5 and 6. And that's all the factor pairs that we have. Now, of course, we can't have both of these factors being positive. One has to be negative in the end to make this, when it's multiplied, negative 30, right? We need to remember that the minus sign is part of this term to make this 30 a negative. So is there any that seem like they come close? I mean, 1 times 30, of course, doesn't. Yeah, some of you guys noticed it already, right? 2 and 15 isn't really close. 5 and 6 is pretty close, but it's still not there. It's the 3 and 10. The question is, which of these would we have to make negative in order to make the addition problem a positive 7? So that's what I'm going to do. I'm going to make the 3 a negative, because if I took negative 3 and added the 10, I would get that middle coefficient, 7. Okay? So this means I can set up my two binomials. Remember, we got the x's first, but then we just take those two values. We have the negative 3 Okay, so there's the first one, -3, and then the second factor was 10. It's positive 10, so I should just show it as plus 10. And again, you could multiply these if you wanted to, or just felt the need to, and just make sure that you end up with a simplified expression like this: x to the power of 2 plus 7x minus 30. Well, I said I'd give you guys a chance at this one. I know it's a little different, but I think you can do it. Try this one out, see how you do, and then we'll go over it, okay? So I'm going to use the rule on this one, but I'll show you why it works with factoring by grouping. So remember, we got our two binomials right here. Now, the problem with this one is we got the a to the power of 2 and then the z to the power of 2 on both ends on this. That means that both terms are automatically going to have an a and a z for both. Okay, and you can see, like, if you went to distribute here, like the second term would be a times z, so see how we get the az's, and even the third term here, the second set of distribution, z times a, would again give us an a times z right there, okay? So really all I'm doing is looking for two factors of 40 here that you're going to add up here to -14, right? So 40, again, you could start with 1 and 40. You could say 2 and 20. Again, I know that there's nothing really close here between these two to get to -14, or 14 in general. It's not divisible by 3, but 4 and 10 will work. Now, while some of you may notice that 4 and 10 will work, I'm going to continue this by saying 5 and 8, which is pretty close. It's just not quite there. And I guess that's the last one. All right, so 4 and 10. Now, we need to make the addition here to be not just 14, but -14. So what the crap are we going to do here? This is where we're going to make the 4 and the 10 both negatives, because the negative times the negative is positive, right? So now if I went, I'll make those negatives with a different color though. There we go. So yeah, now if I look to add those, I do get the -14 center coefficient there. And so what do I put into those? Well, you've got the -4. And it's just showing as -4z, and then the -10, well, -10z, okay? And you can see if you were to distribute the 4z into this -10z, you do end up with a positive 40 z to the power of 2, okay? Well, as promised, this will work with factoring by grouping, but here's how it works. So a to the power of 2 minus 14 az plus 40z to the power of 2, okay? All right, so we already seen that -14 would split up into -4, and again, that'd be az, and also -10 az. So that'd be a squared minus 4az minus 10az plus 40z to the power of 2. And hopefully you can see right here, even though I need more space, that by grouping these, right, it's my a squared and the -4az, and yeah, I'm skipping a step, but that I'd factor out an a here, which would give me a minus 4z. And then for the second grouping here, again, you can show the plus sign between, so that'd be, I'd have to factor out a -10, right, from both of these. So factoring out a -10, and also a z. Now, let's not forget that z there, and the z's from both. So that give you, looks like a, and again, the -10 from the 40 makes that -4, and then you got the z left over. And then we can see that, yeah, you end up with the a minus 4z factored out, and then you're just left with the a minus 10z. Okay, exactly the same answer that we got up here. So I guess we can box this in. It was, where to go? This one. Yep. I guess it's the same one down there, whatever. So let's do this one. Oh, this one's nice because I see -6. I mean, you could say 1 and 6 or 2 and 3. That's about all we can do with 6. Now, the problem here is it's a -6, right? So one of these has to be negative. Now, the problem here is if you make the one negative and then you add those, you get +5. It's not quite 15. You could say it's close if you wanted to, but if you make the 6 negative, it makes it even further away, so it's not that. What about if we make the 2 negative? Well, -2 plus 3 is 1, so that's no good. What if I make the 3 a negative? Well, 2 plus -3, that's -1. That's garbage. So since I can't find any pairs any factor pairs of -6, that would add up to 15 right here. We just say this one cannot be factored. At least for now. You could use the quadratic equation if you wanted to and come up with some imaginary numbers, but we don't want to do that right now. So, greatest common factor in factoring by grouping. Whenever you factor, and right now we're just kind of getting used to these rules, these little, I don't know, factoring by groupings. I'm just factoring in general. But whenever you look at a problem, and I know I didn't really emphasize this before, but I should have, okay? You should always look to see if you can factor out any greatest common factor first, okay? Because if you can, you need to factor that out first and then look at what's left over. Because remember that kind of the whole purpose of this section is that the leading coefficient is a 1, phantom 1, right? So if you had like a 6x to the power of 2 as your leading coefficient, doesn't matter what's behind it, you know, some kind of x, and I don't know, 4x plus 8y like this, you should be looking to factor out a 6 because you want that leading coefficient to be a 1, which will then allow you to use the rule that we looked at, okay? I mean, you wouldn't, this one's garbage, but I'm just pointing it out, okay? You should always be looking to force that leading coefficient of x to be 1, x squared. Leading coefficient to be 1, there we go. So like this one, right? We got -4z to the power of 3 minus 4z to the power of 2 plus 24z. Now, not only do I want the leading coefficient to be a 1, but I also want the leading term to be degree 2, not 3. So this means that I should be looking to factor out z's from all terms, and yeah, you can see right now that we will be able to do that, okay? So this one, we may benefit since we're looking to factor the greatest common factor first, which we should always be doing. Let's look at what we can factor out here. Okay, so the -4 I would show is -2 times 2, and then we got the z's look like 2's. That's okay. Okay, so -2 times 2 times z times z times z, and then the -4z to the power of 2, again, -2 times 2 times now just 2z's. And then 24, I guess I should use a factor tree for that one. Seems like we've seen it though. 24, that would be, I'm going to go with 3 times 8, I guess. And then 8 would be 2 times 4, and then 4 is 2 times 2, okay? There we go. So 24 is 3 times 2 times 2 times 2 times z. All right, so we're looking for our greatest common factor that we can factor out. And I see I got not only do we want the leading coefficient to be 1, but it should be positive 1, right? So that means that I'm going to kind of, on that last term in green, and again, give myself, I'm going to make this to a negative right here, but I'll give myself another -1 there, okay? So again, that if you multiply these all out, the numbers, you get a positive 24 still, okay? So now, yeah, that gives me -2 times 2, -2 times 2, and -2 times 2, right? Which would result in -4. But also the z's, don't forget that you got z's in common there. Forgive my handwriting. And then whatever's left over, we'll put in the parentheses, okay? So in red, we got the 2 z's, that's z to the power of 2 because they're being multiplied. In purple, it's just a z, that's a positive z. And notice here that the 2 signs changed for those 2 terms, which means this one should change. And so -1 times 3 times 2, that appears to be -6. Okay? So this one has that greatest common factor, which we pulled out, okay? And now that we have that, we have this trinomial, this quadratic, with power of 2, and the leading coefficient is 1, which means we should be expecting, I'm not guaranteeing, but we should expect this then to factor out into 2 binomials. We'll keep the -4z, though, out there in the front, okay? So we're looking for 2 factors of -6 to be a 1, right? So again, you can list them all, 1 and 6, and 2 and 3 is not very many. But I know 1 and 6 is going to get me nowhere. So I'm looking at 2 and 3, and I need, when I add them together, to be +1. That means the 2 will have to be negative, right? Because Negative 2 times 3 is negative 6. Just when I add those together, I get my positive 1, which is what I want, okay? So those are the two values that I'm going to be targeting here. Negative 2, positive 3. Boom. That's it. That's, yeah. Sorry about that. You know, try to use the right letters. Try to do what I'm saying, not what I'm trying to say. Or is it the other way around? Whatever. Use the right letters, okay?